Hello everyone. Welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something.
The steps involved in the DBSCAN algorithm can be summarized as follows. DBSCAN starts by examining each point in the dataset and considering its EP's neighborhood. If the EP's neighborhood of a point P contains more points than the specified min PTS threshold, a cluster is created with point P as the core object. This means that P is a central point within the cluster. Next, DBSCAN iteratively aggregates objects that are directly density reachable from the core objects. This involves expanding the cluster by including points that are directly connected to the existing cluster members and satisfy the density criteria. This process may also involve merging of density-reachable clusters if they share common density-connected points. The algorithm continues this iterative process until no new points can be added to any cluster. At this point, all density-reachable points have been included in clusters, and the clustering process is considered complete. Parameter settings for DBSCAN can be described as follows. DBSCAN requires three input parameters. Dataset D, the dataset on which the DBSCAN algorithm will be applied. Min PTS, the minimum number of points within the neighborhood of a given point required for that point to be classified as a core object. This parameter determines the density threshold for core objects. EPs, the neighborhood radius or maximum distance allowed between 2 points for them to be considered neighbors. This parameter defines the size of the neighborhood surrounding each point. The value of EPs can be determined by analyzing the k-distance graph. Plotting the k-distance graph helps visualize the distances between each point and its kth nearest neighbor. It is recommended to select the EP's value at the inflection point of the graph, where there is a significant change in the distances. Choosing an appropriate EP's value ensures that the clusters are well defined. If EPs is set too small, many data points may remain unclustered. On the other hand, if EPs is set too large, multiple clusters may merge, resulting in fewer distinct clusters. The min PTS parameter should be set to a value greater than or equal to 3. If min PTS is chosen too small, points in sparse areas or clusters with lower densities may be considered as boundary points and not used for further expansion of the cluster. Conversely, if min PTS is set too large, neighboring clusters with higher densities may merge into a single cluster, leading to the loss of separate clusters. DBSCAN starts by examining each point in the dataset and considering its EP's neighborhood. For each point P, if the EP's neighborhood of P contains a minimum number of points min PTS or more, a cluster is created with P as the core object. This means that P is considered a central point within the cluster. Next, DBSCAN iteratively aggregates objects that are directly density reachable from the core objects. This involves expanding the cluster by including points that are directly connected to the existing cluster members and satisfy the density criteria. This process may also involve merging of density-reachable clusters if they share common density-connected points. The algorithm continues this iterative process until no new points can be added to any cluster. In other words, when all points in the dataset have been examined, and there are no more points that meet the density criteria to be added to any existing cluster, the process is considered complete. As shown in the figure, the relationship between the sample points Q, M, P, S, and O can be analyzed as follows. Point M, P, and O are considered core objects since their EP's neighborhoods
contain more than 3 points.
Point M is directly accessible in density from point P, indicating that P is a core object and M is within its EP's neighborhood. Point Q is directly density reachable from M, meaning that Q is within the EP's neighborhood of M and satisfies the density criteria. Based on the previous results, Q is densely reachable from P, as it is reachable from M and P is also a core object. However, P is not densely reachable from Q, indicating an asymmetric relationship between Q and P. Similarly, both S and R are densely reachable from O, as they are within the EP's neighborhood of O and satisfy the density criteria. Therefore, O, R, and S are all density connected, meaning they are reachable from each other based on the EPS and min-PTS criteria. The DBSCAN algorithm is characterized by its insensitivity to noise and its ability to handle data with different shapes of distribution. However, DBSCAN still faces challenging scenarios. For example, when the data exhibits varying density gradients, there could be cases where clusters exist within different density gradients. Additionally, this algorithm might not perform well in high-dimensional situations. To summarize today's content, we've gained an understanding of the basic principles of the DBSCAN algorithm and explored some of its pros and cons. We've learned about important concepts in DBSCAN, such as EPS epsilon and mins. It starts by selecting a data point and expanding its neighborhood within a specified radius EPS to form a cluster.
It iteratively adds nearby points to the cluster if they meet the minimum points MLMPT's requirement.
DBSCAN can find clusters of varying shapes and handle noise points effectively. It's particularly suited for datasets with irregular density distributions. That concludes all the content for this lesson. See you in the next class.